Okay, I will start now. Hello, my name is Tatsuya Morikawa from DXC Advanced Solutions, and I'd like to do some demo for HPA and VPA. This is a final presentation for the HPA and the VPA demo series that I've been done before, and then today, so today, I would like to focus on the HPA and the VPA for easy resource tuning demo because people are using the HPA and the VPA already, and then I think that they know that basic of the those autoscalers. So I would like to focus on that how leverage those HPA and VPA autoscaler for your resource tuning in your application namespace. And then all demo I'm going to show you today is described in this GitHub vc-gov-c docs. I hope you can see this link, but yeah, if you unsure that what I'm doing in this demo, please refer to this document, right? And then next. So using the HPA and the VPA, you can set up the resource tuning for your application. And then this is there's a 7 steps. So for to use the VPA, you can run the optimum resource settings for your deployment. And then step 1, identify your deployment in your namespace. Step 2, create a VPA object. Step 3, let the VPA object run a little bit. And then to know that what's that your application usage status. And then review that recommend. So a VPA is going to output recommendations for your application. So we're gonna review that recommendations, and then what does that mean, you know? And then step 5, using those recommendations, we're gonna manually scale up your deployment, and then see what's going to happen to your application. All right, and then last 2 steps, we are going to use the HPA to make your deployment scalable. So step 6, create a HPA object and then deploy. And then this is a key steps in this demo. So that you should calculate how you can set up that threshold for the HPA using the CPU limit, and then also a limit and a request, and then plan out that how you want to scale out for your application. And then step 7, run some tests. I hope I'm going to use the K6 load tester, and then I hope it works, and then see how to go, and then play around with a little bit, right? And then let's do it. So here, I prepare some application, demo application. I deploy the simple application, like there's 2 parts. That deployment has 2 parts, one for 2 replica set, yeah. And then within that part, there are 2 containers, one for the web server, another one for that. It's called the date. I named the date container. I just outputting the date and then put information into the web server so that you can see this website, right? I deployed it. I exposed this URL to the outside world so that every time you click it and just shows the date, and then if and then shows the current replica set. Currently, it's just a 2 replica sets because 2 pods is running. All right, and then I set up that some command to show that the console dashboard, and then so you can see that the 2 pods running up and running on the this is a KLab cluster. This is a node that pod is running. One is running on the app 3, and then another one is app 4 node. And then here, VPA status. If we deploy the VPA, and then VPA is going to increase your application, you can see some description here. But today's demo, I'm not going to use the VPA for expanding your application. Just we are using the deployed dry run off mode. So we won't see any output here for today. And then next line is the showing the CPU request and the memory request, CPU limit, and the memory limit that currently have that is currently set up in that your container. So there are the 2 containers, right? So one for 10 millicore, another one for 10 millicore for each containers, and so on. This is for memory, and then this is for limit, CPU limit, and then CPU memory limit. All right, and then okay, so in the deployment, what I have set up the deployment is that just a moment. So I set up 2 containers, as I mentioned, and one container has the NGX container with the these limit and then request. So I just set up the CPU 10 millicore. It's really small, and then memory 50 megabyte. It's also really small because for this is a testing purpose. And then limit, I set up the 50 millicore and then 200 megabyte, right? This is for NGX container. And then another one is running the some command, bash command, and then outputting the contents of the website. And then I set up that also really small request, 10 millicore, and then 25 megabyte, and then 25 millicore and 200 megabyte for the limits, right? And then replica set, I set up that replica set, 2 replica sets currently. Set up the 2 just a moment. Oh yeah, here. 2 replicas created, right? Right. A little bit slow. Okay. So now we have 3 steps. So that's the step 1. So identify the deployment in your namespace. So my namespace is the tax autoscaling demo. That's my namespace. And then within that namespace, I have NGX Hello World as demo deployment, right? And then, okay, next, we are going to create a VPA object. So I prepared the VPA like this. I made example VPA recommender YAML. It's a dry run, really simple off mode VPA. So I set up that my VPA name You can set up whatever you want. Just I set up the example VPA recommender for now for this demo. And then you can set the deployment object, what kind of object you're gonna use the VPA. So in this demo, I'm gonna use a deployment. So it's kind gonna be the deployment, and then deployment name, hello world, nginx hello world as demo. And then this is important. We're gonna use the off mode dry run, right? So currently we don't have any VPA object within this namespace. Just to make sure that no resource found in the namespace. So no VPA object. So I'm gonna deploy this one. Dash file name f, just in case. Just put make sure that your namespace. I don't need usually it's not necessary to specify the namespace because it's already mentioned that oh no, it doesn't have the namespace here. Okay, yeah, better to specify the namespace here, right? Then let's create it. Okay, created. Now in the console dashboard showing the VPA object here. It takes time a little bit to get for the VPA. It takes a little bit time to get CPU memory status. So let's wait for minutes or so. Then see how it's gonna. While we are waiting. Yeah, it's created. And then let's check. Yeah, now you can see that now got the recommendation, right? But we remember we have two containers, right? So, but this just OC get VPA shows just shows the target recommendation just for one container. So we want to know that the details of the recommendation. So in that case, you want to run that OC get VPA -o YAML. That. So this is the current status of the recommendation, right? So you want to check that under the recommendation section. So there's two containers has been recognized by the VPA, one for nginx, another one for date. So for the we just deployed the VPA minutes before, right? So it doesn't have any historical data yet. So ideally, you want to run this VPA at least 24 hours to know that these recommendation is correct. And then I recommend you want to run that this VPA recommender for 1 week or so, and then so that these values are more gonna be more accurate. But then for this demo, it's a just demo, so we're gonna use these recommendation values for now, right? So VPA thinks nginx container has is lower bound 12 millicore and 131 megabyte for the minimum request, and then target. This is a target, and then uncapped target, and then also upper bound is like this. And then another one for date container, a little bit higher than the NGX. So 22 millicore is a minimum, and then target 23 millicore, and upper bound 43, right? So we're gonna use these recommendation for your for our application limit setup, application limit and request settings. So how we gonna do it is that just a moment. So we just run that step 3. Let the VPA Objects Run, and then we review the recommendation generated by the VPA object. So we're gonna do implement resource request and the limit recommended by the VPA object, right? So taking these recommendation values into the notepad or something. And we're gonna edit deployment. This is a lane. So there is the many discussions and calculations how we want to use these recommendation into your limit and the request settings in that deployment. But the most simplest way to set up that these recommendation into your deployment is that use the lower bound here or target this one as the request here. So you want to set these value lower bound or target as a request here for the memory and the CPU both. And then upper bound, this one, for the limit, right? Because the here is the simple graph for the request and the limit relationships. And so there's two resources, CPU and the limit and the request, sorry, for the CPU and the memory. And the meaning of the limit and the request for the CPU and the memory is a little bit different. So request is almost same. As you can see here, for the CPU, request means that the amount guaranteed by the Kubernetes. So usually, if you set a CPU request, usually Kubernetes is running using within this request CPU usages. And then if things are a little bit usage is high, Kubernetes is going to bump up your CPU usage within the limit. So it's called a burst mode, like bumped up that your CPU use request. So if you set a 100 millicore here, and then if you set a limit at 200 millicore here, so if things really needs to use more CPU usage, Kubernetes is going to use a 200 millicore, right? And then if hit the limit, CPU usage is hit the limit, Kubernetes is going to throttling your application so that you might see the performance issue, like really showing the web page is really slow, or sometimes cannot connect or something like that. But then that's still process is up and running. All right, that's the CPU limit means. But then the memory, on the other hand, so Kubernetes request is like same as the CPU, but then the limit, if hit the CPU memory usage, hit the limit, Kubernetes going to kill that process. It's out of memory. It's called OOM in short. So you want to avoid this scenario, right? That's the difference of the CPU and the memory limit and the request meaning. And then, so we want to set out the memory a little bit higher than the, a little bit high, so that you can ignore that, OOM scenario. But then CPU request limit, maybe you can, yeah, process is not going to kill by that CPU throttling. You just see that the slowing down the of your website, web application or something, right? So we want to use the threshold CPU. We want to use the CPU for the HPA threshold for this reason. And then in here, NGX VPA recommender is showing like these recommendations. So we want I'm going to set up this request and then limit for this deployment. And so NGX, I'm going to use the target 12 millicore. Currently it's 10. The memory. Maybe byte. And then at the limit, we're going to use so limit shows you that 20 millicore, but I'm going to set up that like, well, I'm going to stick with this one a little bit higher, because I don't want to have the OOM just in case. And then VPA is not going to show you that sudden CPU spikes. So I really would like to recommend to see that check to see and check the CPU and the memory trend using the other tool also. Not only rely on the VPA. There's lots of tools in that OpenShift one. Yeah, like a Sysdig or Grafana, stuff like that, or Prometheus. Please check those tools to know that these values are correct. And then, yeah, this is for the NGX container. And the other one, date. So it said, I'm going to use a target for now. So 23. And 131. And limit 43. This one a little bit, it showed a little bit higher than the default. So So let's say 300. Because I want a little bit to put that it shows at 241, but a little bit I set a little bit higher than the recommendation. Okay. And, okay. As soon as change the deployment, Kubernetes is going to recreate the container with the new here new request and limit. Okay, so now two pods, both pods has a new CPU request and limit. Okay. So we have manually expand your application, our demo applications, rather than using the VPA's auto mode. Okay. And next step, we're gonna use the HPA. For HPA, I prepare that. So here's the so usually how you set up that HPA threshold is that really depends on that your preference. In this demo, we want set up the 80% of the average utilization. Then HPA is going to create another pod. But then here is a little bit confusing part. So you can say that the average utilization. Okay, I want to another pod if CPU usage hit 80%. We are using a CPU here, and then, but then this 80%, what does that mean, right? So this graph again. So we're gonna stick with the CPU, right? And then HPA is always looking at the request, not the limit, right? And then here, 80% means that against the request. So maybe something around here. If you just set the 80% here, but then we have more room to the until limit, right? So it's kind of makes sense if set up that like 80% of limit, right? So if hit like here, 80% of the limit, then we want to create another pod. That's much more makes sense. And so, but then you need to calculate. This is because the HPA is always looking at the average utilization of the request, not the limit. So you have to calculate using this formula. So formula is like this. So it's really simple. Total limit multiplied by the target percentage against the total limit. So you want to set that 80%, then here it's going to be 80%. And then divide by total request. Total limit and then total limit means is that these both values. So if you have two containers, you have to add both of them. So 20, currently we set a 12 millicore for CPU, and another date container has 23 millicore. So it's gonna be 35 millicore in total, right? And then that's the total request. And then total limit means that here, 50 and 43. So 93 millicore. So let's check. Here's this example was that it's not showing the this current status, because the I tested at different applications, so that currently a little bit different. So currently we have total CPU limit is at 93 millicore in total. We want to target 80%, means that 0.8, right? And then total CPU request is the 35. And let's calculate. All right, 93 multiply 0.8 divided by 35. So 2.1. So about 200, 2, let's say 3, 230% of total CPU request. That's the target percentage of the your application, right? So if you want to set the 80% here, then you want to change this to 3. All right, so I'm gonna deploy this HPA into my application. I'll just check that one more time. Namespace is correct. Objects deployment name. So deployment and then deployment name and the namespace. That's scale demo. Yeah, within the HPA object, you have to specify the namespace. Right, seems correct. So let's deploy this one. This specify the namespace again. Okay, so on the dashboard, it's showing the HPA object. And then currently it's calculating. So wait for the minutes or so. Oh, now, yeah. So this is the current percentage of the usage against your request, not the limit, right? So 40%, 41% is you used, and then target is at 230, 13%. Yeah. And then currently it's 2 pods is running, and then maximum pods. I have to show this one. So maximum replica set is set to 10. You cannot go further over the 10. This is a really max in our cluster environment. 10 is max. Right? So again, so in this demo, we use a VPA as just get some recommendation, right? Not really using the autoscaler. So we don't want. There's a couple of reasons why we are not using a VPA as a autoscaling, because the because the some considerations around that VPA. Yeah, VPA needs to evict the pod recreated. So you have to VPA have to kill the your pod once and then recreate it, and then you don't want to that happen outside of the your change window, right? So we expand your pod manually, of course within that your change window, right? We want to control that, and then use the HPA for that real autoscaler. HPA is just adding the pod so that you don't need to have the change window for your application, for that expanding your application pods. So that's much easier, and then for your application. And then we set up that CPU HPA threshold against the CPU limit, not the request. So if you want to 80% hit the 80% of the CPU limit, then pod is going to increase the Kubernetes is going to increase your pod, not a request, right? So that's much. Yeah, because the your pod is running under the burst mode, right? So you want to use that limit as much as possible, and then if you really hitting the if usage is hitting the your limit, you want to increase the pod. And then, of course, after increased after you got a 10, okay, now I got a 10 pods, and then HPA is going to decrease to that, and then come down the usage. Then HPA is going to decrease the your pod one by one, and then I think the default checking interval is 5 minutes or so. So until default replica set, going to the default replica set a little bit takes time, right? And so here is the again, here is the formula for the HPA threshold calculation. Because this is necessary, because the HPA is always looking at requests. So you want to calculate this formula, right? Okay, last step. Check that the HPA is going to work or not, and then your application load test is okay or not. So hope it works. I prepare that some K6 really simple load tester, just hitting. Yeah, in this load test, just hitting this URL and then get that 200, check that 200 response or not, and then see what's gonna happen. So I'm gonna set 600 virtual users during the 5 minutes. Let's run it. So here's the current usage, and yeah, a little bit increasing. I hope it's hitting the 200%. So here is the Grafana I'm running, and then yeah, it's seeing that lots of access to the cluster. This is a HA proxy router status, not it's a whole cluster-wide router session count, not only for that names for this namespace, but anyway, it's hitting the clusters, and then yeah, on 37% now. Maybe I have to lowering the this percentage for the demo. Just a moment. I'm gonna stop that test, and then for that demo purpose, I'm gonna change the HPA values. So you can see on that 37. So let's say 110%. So I'm gonna set up that 110% for the demo. Oops. So we'll see apply. Okay, so you can see change the target under 10%. Now I'm gonna run that this test again. Increasing a little bit. HA proxy is having the lots of connections. 7%, a little bit more. Oh, and also this percentage is the average percentage of the 2 pods, right? So 42. See, now we have another pod here. 3 pods now. HPA increase the expand the pod. because the it's over the threshold. Okay, I'm gonna stop that this load test. Wait for a bit. I think it will take 5 minutes or so. They're waiting. I'm gonna check that the HPA status. Live HPA. So this is the name. Yeah. So OC, you can run that OC describe HPA and the HPA name. You can see that event, and then event said that successful rescale horizontal pod autoscaler. A new size is 3. Reason CPU resource utilization percentage above the target. Target is 110%. So that's why we got 3 pods. Just curious that I'm gonna check the VPA also. Yes. So as you can see that VPA is same as before, I think. It's not changed the, not really changed the previous values. This one, actually memory was a little bit below than the before. So as you can see that the VPA is not really catch the spikes. So, but then that the whole point of the VPA is that getting a trend for the long-term period. So yeah, this is another reason we are not going to use the VPA for the auto scaling, because the VPA is not good for the sudden spikes. So if you really see that sudden spikes within the HPA, your application, we recommend to use the HPA instead of the VPA. Hey, Matt.
Hey, Ted.
Yeah, so I think it will take a little bit time to decrease that this part, maybe 10 minutes or 5 minutes. So you want to wait for that, or?
No, I don't think we need to wait for that. I think that's clear from your demonstration there that yeah, after that period of time, if you were monitoring for longer, you would see those replicas scale back down to 2, back down to their minimum level, right?
Yeah, yeah, it will. Yes.
Okay. Well,
So that's it. Then my presentation is done. So any questions or?
I think that's it. I think that's great and really clear presentation, and I think really good to see how the resource utilization can be set higher than 100% to make sure that you're taking advantage of that full burstable range. As someone who's new to OpenShift, that was something that wasn't immediately obvious to me, but is now very clear after seeing your presentation. So thank you very much for putting this together, and we'll make this recording available for anyone who's interested in learning more about this topic.
Okay. Yeah, it's kind of really complicated. Well, it's kind of really confusing part for the resource request and the limit. And yeah, I hope everyone get some idea of those, and hope that everyone's application is running happily.
Thank you.